Okay, welcome back. So here I'm being told that a circle with center 2, 5 passes through a point at 8, -6, and it wants to find the equation of a circle. So one thing you need to remember here, in order to find the equation of a circle, we need two things. We need the radius, and we need the center. Now thankfully I'm giving you the center. It's at 2, 5. But I need to find the radius. So think for a second how I might be able to find the radius. Now I'm told the center, and I'm told the point that's on the circle itself. So the distance from the center to any point that's on the circle should in fact be that radius. So if we want to find the radius, we need to use we need to find the distance or the length between that center and that point. So we're going to wind up using the distance formula. So if I do that here, and I get d squared, just d equals the square root. Remember, it's x2 minus x1 all squared, so I'm going to go 8 minus 2 all squared plus -6 minus 5 all squared. Okay, so again, what I'm using is the distance formula between the center that I was given and a point that's on the circle, because that distance between the center and a point is called the radius. So 8 minus 2 is 6, so I get 6 squared. -6 minus 5 is -11. So I wind up with 36 plus 121, which gives me the square root of 157. Okay, so that's going to be the actual radius for my circle. So putting all that together, I should be able to find the equation. So remember the general form of a circle, x minus h all squared plus y minus k all squared equals r squared. So with my centers at 2, 5, I'm going to get an equation at x minus 2 all squared, y minus 5 all squared, and for my radius, well, that radius is root 157. If I take the square of square root of 157, it cancels out the square root, so I wind up with 157. So this right here should be the equation of my circle. Notice I still have my variables x and y. I need those to show that relationship, but I put in my center at 2, 5 and my radius at square root of 157. Okay, so one last one to look at here. So I'm giving you a circle, x squared plus y squared equals 40, and it wants you to tell me if the 3 points given, if either of them, if they lie in the circle, on the circle, or outside the circle. So take a minute, either on your own or with a partner, think about how you could figure this out, and then push play and you're ready to go through it together. Okay, so a couple things that I can tell you about this circle here. The center here is going to be at 0, 0. Okay, and the radius is going to be the square root of 40. So one way you could determine if these points were in, on, or outside the circle is you could use the center that's here, and you could find the distance from this center out to each of these points individually. So basically use the distance formula 3 times. So you could do distance from 0, 0 to 5, -4, 0, 0 to this one, and 0, 0 to -3, root 31. And we can compare that distance to the actual radius, and that will tell you how far away from the center of the circle it is. So that would be one comparison right there. So if you wind up getting your radius being exactly root 40, then you know it was on the circle. If the distance there was more than root 40, it would be outside the circle. If the distance was less than root 40, it would be inside the circle. So that would be one way. That can take a little while though to calculate all those distance formulas. So while that certainly does work, it might be a faster way. One thing you can do is you can just do a little bit of a check inside the circle here. So basically what you can do is you can sub the point, each of these points inside the equation of the circle, and compare what you get for the left side of the equation, the x squared plus y squared, to what you get for the right side. So here's what I mean. Let's say I take the point 5, -4, and I split up my equation x squared plus y squared equals 40 into a left side, right side scenario. Basically like we're doing a check. So if I put in 5 for x and -4 for y, I get 5 squared plus -4 squared. So that gives me 25 plus 16, which is equal to 41. Okay, so my left side is actually larger than my right side when I try to use, when I try putting that 0.5 negative 4. Let's see what this means on a graph. Okay, so on a graph, I've put in a graph of x squared plus y squared equals 40, and I've thrown in the 0.5 negative 4. So it looks like it's really, really close to the circle. When I zoom in really, really close here, I can actually see that that 0.5 negative 4 is outside the circle. So that's what the math is telling me over in this lesson here, is that even though, since the left side is larger than the right side, this point right here is outside the circle. Okay, so what I'd like you to do now is repeat this process for the other 2 points and see what kind of answers we get. Again, if you choose to not use this method and instead choose to use the distance formula from 0, 0 to each of these points to then compare it to the radius and see if it's inside or outside the circle that way, that works perfectly fine. But again, try something with these last 2 points and try to find out if they're inside or outside or on the circle. Okay, so just to quickly finish this one off here, take a look at the math I did for each of these. So with the point 1.696.08, I subbed it in the equation for x and y, and I wound up with the left side of 39.8225. When I took a look at my graph on Desmos here, the point 1.696.08, again, when you zoomed out, it looks like it's actually on the circle, but if you zoom in really, really, really close, and I mean really, really, really close, you'll see this point is actually slightly inside the circle. And again, you can see that from the equation, from the fact that what you got on the left side is less than what you got on the right side. So this one would be located inside the circle. For the last one at negative 3 and negative root 31, when I sub those values in for x and y and work through the algebra, I end up with exactly 40. So that would tell me it's on the circle, and let's confirm that with the graph. So negative 3, negative root 31. Zoom out here, so that would be a purple dot. So somewhere down here, there it is. And again, the more you zoom in, you can actually see how much this point is exactly on the circle, not inside or outside. Okay, so again, that's a way you can tell just by looking, just by doing a left side, right side check and comparing the left side to the right side. Okay, so that's it. Okay, hopefully you don't find this too bad. There's some homework there plus a worksheet. And again, just please come see if you have any questions, because these can be a little bit tricky to work with. Okay, cheers.